Hi there, this is LT Survival, and in this episode we'll see part 5, well, the first part of part 5, bearings. Stay tuned, we'll be right back. As I said in the intro, this is going to be the first part of the Map and Compass navigation series, part 5, but the first part of it, because there is kind of a two aspect to it. One is the theory about the bearings and what it is, mainly words basically, and the second part is the actual application. For the application, we'll have to do a mix of outdoors and over the top on the table for that, and that's going to come in the next week. Beautiful weather is coming, so it's going to be easier to do some outdoors video. So in the first part, first of all, let's come back to history. In ancient times, the Chinese invented the compass, and they invented the compass rose, which was basic division for our direction. The compass rose was basically 4 cardinal points, which are the classical one: the north, the south, the east, and the west. And you have to remember, east is always to your right as you're looking north, okay? And west is always to the left. So those bearings were really rudimental. So they wanted to have a more precise way of navigating their ships, mainly. So they decided to subdivide the compass rose, which was the cardinal points. They decided to go with the intercardinal points. So basically, what lies in between north and east is called the northeast. I'll show you a little compass map. The northeast, and then in between the east and the south is the southeast. And then you have the southwest and the northwest, basically 4 cardinal points, 4 basically intermediate cardinal points. To further refine their compass rose, they decided to add 8 intermediate points. So basically, the division, basically the half division in between the intercardinal and the cardinal points. So it's a mix. It's really a simple way of doing it, because we have the north, the south, the east, and if we divide for the intermediate, divide between the north and the east, it's the northeast division. So the same principle will apply with the intermediate points. So basically, in between the north and the northeast, you will have north by northeast. Okay, so basically north northeast, we've simplified it. Okay, it kind of said north by northeast. So you're higher than northeast, and you're in between north and northeast. So it's kind of a obvious way of doing it when you think about it. So if what's in between east and northeast? Well, you've got east, northeast, using the cardinal as your main call. So basically north, northeast, and then east, northeast. The same apply all around the map. You'll see here a full cardinal, full compass map. No, say that again. A full compass rose, and it's going to be basically, you're going to be able to go through north northeast, east northeast, east southeast, south southwest, west southwest, and then west northwest and north northwest. So we've gone around the whole compass rose. Okay, not complicated. It is basically subdivision, half subdivision of all the distance in between the points. Then we came to a scale compass, basically numbers around the compass. The first one that was divided was a 360 degrees. It was an easier way of divided because we had established that the arc of, well, basically we had divided the hours, and that brought the latitude longitude grid on Earth, and it's basically divided in degrees. So those degrees were a common application for your compass. So you have compass, rudimentary compass, that have degrees. Other compass like this one is in degrees also. And you have the other system. The degrees is basically a circle that's divided by 360 division, basically angles. Okay, it's the most common. So you've got the north, which is either 0 or 360 degrees. You've got east at 90 degrees. You've got south at 180 degrees, and you got west at 270. So that's kind of an easy one also to remember. That's the one in mathematics we're using. That's why it's been adopted for compass at first. Okay. Later on in history, we decided to go with Mills military. Well, it's a military application. It is a use also for in French we say arpentage, which basically is dividing your terrains and everything, knowing where things are. So Mills is a milliradiant. It's a metric milliradiant. Basically, the circle, instead of being divided by 360, will be divided by 6,400 division. A little more precision if you can view the angle. Of course, your compass, it's not going to be as obvious, but it is a little more precise. So the division are again equal angles from 0 to 6,400. Basically, north 0 to 6,400 mils. South is 3,200 to 3,200 mils. East is 1,600 mils, and west is 4,800 mils. Okay, so that makes for a different compass rose. You can see an image of those. They've been overlaid as I was talking. The other thing, in navigation, we use 3 norths. Okay, there is 3 norths on the planet. There is the magnetic north, which we all know where all the longitude line will intersect, and is the axis of rotation of the Earth, which points Polaris. Okay, the North Star. Basically, this is the true north. It's also referred as true north. It is the geographical north. Okay, we've got the magnetic north. It's where the needle points. Okay, which is not exactly to the true north. It is somewhere in the Ellesmere Island, north of Canada, in the Arctic, basically, where the magnetic North Pole is. Basically, the axis is pointing the North Star, but the magnetic pole is not exactly at the same point. I'm going to show you the image again. This is more theoretical. That's where they measured that the magnetic pole was coming out of. Okay, and it tends to vary years to year. It wobbles. Basically, it's because of the spin of the mass of the liquid metal in the Earth that you will find that will create the magnetic field of the Earth. And we all seen a representation, which I'm going to show again, in overlay, of the magnetic poles. Okay, your needle will be pointing there, so there is some importance to all those norths. And the last north is the grid north, basically, or the map grid. Any maps that you will be using will have a grid on it, even the latitude longitude ones. Basically, you see there is a grid, and all the lines, if you go upward towards the top of the map, our line points to the north. Okay, basically we have here a symbols, a representation of the three, right here. Okay, we've got, I have difficulty to see in my screen, so basically we've got the three north represented here for this map in particular. If you're on the west side of Canada, this will change a little because the magnetic north in relation to the North Pole is not exactly the same way. Mainly your grid map will change. Okay, and I've learned that going to the Arctic because a declination, the magnetic declination. Oh yeah, that's a definition I didn't put in my notes. The magnetic declination, we'll see that further down into the navigation, is the difference of angle in between magnetic north and the map north. So, often the grid north is outside of the map north, of the north of the map, and that makes for that angle to be taken into account, because once you're navigating from a map to a compass, you have to compensate for one using true north and the other one using the map north, the grid north, and the other one using magnetic north, not pointing exactly the same direction. So you have to be careful with that. There is a way of compensating your compass to be able to walk the terrain according to what the map says. So basically that's another stuff we're going to see further down the line. So what's a bearing? Basically the bearing is an angle from a zero towards a point. Okay, basically if you're going between 2 points, that line is at angle with your grid map or the north, or the magnetic north. So that way you have to be able to calculate those bearings so you can walk those lines. And there's three different bearings. There's the magnetic bearing where you're using a compass. Okay, there is the grid map bearing. It's 2 point on a map which you calculate between the north line, what we call the easting, okay, which is the north and south line of your map, and the back bearing. What's the back bearing? You'll see it's the direction to return on the same line that you had going towards a point. And that's important because that's language, but that's important also because it's a way of coming out of where you went in. Okay, you can use a back bearing. Okay, so that would conclude that first introduction. One point I want to talk to, when you're using basic compasses for your foray into the wild, there is an easy way, and we always use that as in the military as a safety bearing. Okay, safety bearing is when we hit a target, for example, and thing goes awry, then you've got to evacuate and make sure you go somewhere to regroup. Basically, we're using emergency bearings, or if you prefer, safety bearings. So basically, it's a direction, you know you're going to hit a known feature, and that feature is going to be the axe towards which you're going to be regrouping. For example, you're going on a hunt. You're using a road, basically a field road to be able to access your hunting point. And then you're going hunting to the north of that road. Okay, and your safety bearing would be coming back to the south and hitting the road. Does not matter if you come out exactly where you entered, but you know you're going to hit the road at one point. So that way you can exit by a known bearing. That could be a direction you've taken, either perpendicular to your road. You're gonna, if you know you're gonna go in and east into your territory, maybe your safety bearing is going to be south. So you're going to know that if you're coming straight south, you're going to hit somewhere in between where you entered and where you were. And that's going to be then going south or east or west along the road to be able to hit your car, for example. So it's a way of navigating in a territory where you're not necessarily following the exact bearing, but you're going into a general direction. You do hunting, for example, then you're going to move towards prey. And then when you want to come out, make sure you come out to that emergency bearing or safety bearing, hit that road, and usually if you plan it the right way, you'll be either ahead of your vehicle or back of your vehicle. So you can choose either, and you can make certain that you'll hit the road ahead of your vehicle by choosing the right safety bearing. So basically, not choosing exact entry direction, but a angle to which you want to come out, and then you're going to come out to your road. If it's for example, the road goes northeast, and you're hunting northwest, basically, or northwest towards and turning